Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay. An astronaut is said to have tried to get out of a traffic violation for running a red light wavelength lambda equal to 650 nanometer, nano meaning 10 to power minus 9, by telling the judge that the light appeared green with wavelength lambda equal to 540 nanometer to her as she passed by in her high powered transport. If this is true, how fast was the astronaut going? Dear students, in this problem, because wavelength lambda is involved, so we will also discuss a little about the spectrum of electromagnetic radiation. Okay, spectrum of electromagnetic radiation, and then after this we will move to our main problem. Okay, so we come to its solution, and first of all we introduce two equivalent or alternate snapshots which deal with the spectrum of electromagnetic radiation. Okay, snapshot number 1, table 32.1, wavelengths of visible light. Okay, violet, blue, green, yellow, orange, red. Okay, and their wavelength range is also given in front of these colors. Okay, similarly the second snapshot which is alternate or equivalent version of the above, the only difference is that these two snapshots have been chosen from two different books. Okay, next, in the next snapshot, Doppler effect is defined or described. Okay, Doppler effect, electromagnetic waves, source approaching observer. Okay, F is equal to under root C plus U over C minus U into F naught, where F is the frequency measured by observer and F naught is the frequency measured in rest frame of source. C is the speed of light in vacuum and U is the speed of source relative to observer. Okay, this is about the Doppler effect, and subsequent 2 or 3 snapshots are also dealing with Doppler effect equivalently. Okay, in a relatively alternate manner. Okay, Doppler effect, source observing, source oblique observer approaching, and then source or observer receding. In case of approaching, F is equal to 1 plus beta over 1 minus beta into F naught, where beta is speed parameter V over C. Okay, so in case of source or observer receding, F is equal to under root 1 minus beta over 1 plus beta into F naught. Okay, where beta is the speed parameter V over C. Next, again, this type of second snapshot has been further split into two parts. Next, okay, F is equal to 1 minus beta square under root over 1 minus beta into F naught. This becomes equal to under root 1 plus beta over 1 minus beta into F naught. Okay, approaching case, and F is equal to 1 minus beta square under root over 1 plus beta into F naught, alternatively becoming equal to under root 1 minus beta over 1 plus beta into F naught. This is a receding case. Okay, Actually, dear students, a square minus b square is equal to a plus b into a minus b. Okay, basic formula of mathematics, and this formula has been used here. Okay, dear students, next snapshot, which has been split in two parts, is included just to emphasize the concept of speed parameter, which is denoted by beta. Beta is equal to v over c. Okay, if the relative speed between frames is v, the contracted length L and the proper length L naught are related by L equal to L naught into under root 1 minus beta square. This alternatively becomes equal to L naught over gamma, where beta equal to v over c is the speed parameter. Okay, and gamma equal to 1 over 1 minus beta square under root is the Lorentz factor. Okay, so this snapshot was included in our problem just to clear Lorentz factor and speed parameter. Okay, now we come towards the solution properly. Okay, using the expression f over f naught equal to 1 plus beta under root over 1 minus beta under root, this implies that frequency is reciprocal of wavelength, and we know that f is equal to c over lambda, where c is the speed of light. Okay, in relativity, frequency is equal to speed of light divided by wavelength lambda. So in place of f we will put c over lambda, and in place of f naught we will put c over lambda naught. Here, dear students, c will be cancelled with c because it will be considered as c over lambda multiplied by lambda naught over c. Okay, denominator factor will be reverted and shifted to a numerator. Okay, and hence c will be cancelled. We will get, this implies that lambda naught over lambda equal to this. When in the next step we will take a square on both sides, and hence under root will disappear. Okay, this implies that lambda over lambda naught equal to this, and when we take square on both sides, then this becomes this. Okay, here lambda is 540 nanometer and lambda naught is 650 nanometer. Okay, whole square equal to 1 minus beta over 1 plus beta. Nanometer square will be cancelled with nanometer square. Okay, and we will be left with only numerical value. Okay, units will be cancelled out. Okay, so after simplification it becomes 0.69 equal to 1 minus beta over 1 plus beta. We will shift 1 plus beta in the denominator to other side of equality, and it will be multiplied with 0.69, and hence we will get 0.69 plus 0.69 beta minus 1 plus beta. Okay, actually this factor will be multiplied with this factor, and then this factor will be shifted to other side of equality, and this 1 will become minus while this beta will become plus. Okay, so next, in the next step, 0.69 will be subtracted from 1, and minus sign will dominate because this is bigger value, this is smaller value, and these two beta related values will be added. Okay, so it will become 1 plus 69 beta. Okay, so after simplification we will get this implies that minus 0.31 plus 1.69 beta equal to 0. This implies that beta becomes equal to this. This implies that we know that beta is speed parameter and it is equal to v over c. So in place of beta we have used v over c equal to this. So this implies that v will become equal to 0.183 c. Okay, what we have done, we have shifted c on other side of equality. Okay, so this implies that v equal to this. We have used, next we have used value of c. Okay, so value of c is that is speed of light is 3.0 into 10 raised to the power 8 meter per second, or sometimes in place of 3.0 we write 2.998 into 10 raised to the power 8 meter per second. Okay, so next, just simplification, just simplification, and our value v finally becomes equal to 5.5 into 10 to power 7 meter per second. Actually, dear students, this is 10 raised to the power 8. When we will shift decimal one step ahead, it will reduce by 1. And moreover, because subsequent to 4 figure is 8, which is greater than half, that is 5. So we will uh, we will replace it by 0.5, 5.5. We will convert this 4 into 5, because the next digit is greater than half of 1, that is zero point 0.5, greater than 5. So v has finally become equal to 5.5 into 10 raised to the power 7 meter per second. This is our solution of the problem, and this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.